Hello, good morning, good afternoon, or indeed good evening, wherever you might be tuning in from the world. My name is Anushka and I'm the founder of Naught, and I am so delighted to bring this awesome fireside chat to you this afternoon. I'm really delighted to introduce to you Skylar Tibbits. He's the professor and director of the Self-Assembly Lab at MIT. Skylar is the founder and co-director of the Self-Assembly Lab. He's also the associate professor of design research in the Department of Architecture. His work and team focus on self-assembly and programmable material technologies for novel manufacturing, products, and construction processes. His work on self-assembly has demonstrated the scalability of this natural construction phenomenon with synthetic design and fabrication systems. Imagine a future where cities produce what they consume, global supply chains transform into in-situ resource utilization, and with the AI revolution, can we merge materials and machine? If so, well, let's find out more and let's introduce Skylar. Welcome. How are you? Good morning.
Thanks so much. Good to be here. Thanks for having me.
No, it's great to have you here. Why don't you tell us a little bit about what you're up to currently at the moment, and particularly under this sort of global pandemic time frame that we all find ourselves in? I'm sure it's been a very extraordinary year is what I kind of frame it as.
Yeah, I mean, it's definitely been interesting for us, similar to everyone else around the world. A lot of our work is very much physical, and so a lot of those physical projects have now become distributed physical projects, so machines getting sent to different people's homes or different places, and a lot more collaboration globally. We would previously travel somewhere and install something, but we now are relying on our collaborative partners. But we have a lot of different projects going on, everything from kind of future of toys to aviation components to textiles and fashion, to a project in the Maldives looking at sandbars. So, it's a wide range of materials, fabrication processes, construction systems.
I guess the burning initial question is what inspires you to bring this together? And of course you've adapted you mentioned distributed teams globally and collaboration. That's really at the heart of a lot of innovation. But what inspires you to get up every day and come up with these ideas that you bring to the world?
I mean, there's been many things over the years. Originally, I have a background in architecture. And so a lot of the work originally was critiquing our methods of fabricating or building. And, at MIT, I was really invested in lots of other fields like computer science and material science and robotics. And so the insights that I saw in those other worlds allowed me to rethink how we build in the construction sector. And so it was really challenging. We have these very efficient and kind of automated methods to computationally design things, computationally analyze things, computationally fabricate things, and then we have man-made human assembly. And in the best case, we might have automated robotic assembly. But the kind of key change was through materials that if we can activate these materials, as you said, we can make much more dynamic environments, we can make much smarter products, and we can make the things that we make in a smarter way. And so it really was materials that inspired a lot of this work, trying to activate them in new ways and create a material collaboration. Often we think about human collaboration or robotic collaboration, and we're interested in a material collaboration.
Do you think that historically we've solved problems the wrong way? Are we making things more difficult for ourselves and not necessarily considering our planet? Are we being, I don't know, I mean, you're nodding, so there must be something there.
Yeah.
Have we been just doing everything wrong? Is there a different way of thinking about it?
I don't know about wrong, but I often think that if there's enough money to throw at a project, you can solve whatever it is. You usually just throw tons of money and motors at it and you solve it, but it becomes a brute force solution. And what you'll see is there'll be some super clunky, crazy, expensive, complicated solution. And then over time, it often gets more and more and more elegant. And if you look at the sort of history of manufacturing, we went from craft and trade, where people had intimate knowledge of materials. Think of blacksmiths, or think of people making textiles, or think of woodwork. They would use the material properties to make smarter and better things. With industrial manufacturing, we sort of lost that. It was all about automation, faster, 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 standardization. And now we can sort of bring that back. We can take the intimate knowledge of materials, combine that with efficient forms of construction or fabrication to get new property. So it's not that we've done it in the wrong way. It's just sort of inelegant solutions that are like brute force because we become impatient and sort of ignore the properties of the materials in the environment around us. And so, it's trying to like not jump to those solutions. In the footwear apparel space, everyone wants smarter clothes and smarter shoes. So right now you'll see a trend where people throw batteries and motors in everything. You got batteries in your shoes and batteries in your clothes. And that's a perfect example where it's like no one wants robots in their shoes and clothes. Yes, we want smarter and smarter clothing. Can we skip over that intermediate step and find a way to do it through material properties?
I really love that because when you talk about even like going into the topic of like the reversible construction methods that you talk about, and one of your colleagues at MIT spoke about recycling in nature is a redundancy. And then you've got this amazing reversible construction method. And I was reading that sand is one of, like, after water, the second most abundant source in nature as a construction material, but it's becoming scarcer and scarcer. What can we do to kind of think about new ways to construct buildings if we want these smart cities, if more of us are going to be living in cities, or indeed moving to rural environments? We need to build buildings and homes and offices. Like, what can we do and what's the way forward?
I think it's about reversibility. We can look at the critique of single-use plastics as one terrible example of when we're not looking at it like that. But often construction, like look at concrete, that's a one-way process. And the only way to get rid of it is to destroy it, and you can't rebuild it. Even masonry construction like bricks, it's not the easiest to be able to disassemble. So if we think from the get-go about reversibility, then everything can be built up, broken back down, and built up again. If you think about something as simple as Lego, there's really no waste in Lego. And, that's sort of the crux of the problem when you got Legos lasting forever and you're stepping on them and your kids are using them for decades or giving it to new generations. But that's also one of the beauties of the system, is that something can be built up, taken down, built up again, taken down, built up again. And it's not about going all the way to the molecular level, perhaps, but I think far too often we look at the solution for sustainability as like some holy grail material, but you can look at it from a more macro perspective, that everything we build should be able to be unbuilt, and that we could literally reverse things and reconfigure, reuse, adapt. And, that's a slightly different perspective, but just changing that mentality gives you a whole new perspective on how we can build for a more adaptable and long-term solution.
Can you, as you were talking, I was thinking about some of the materials and mediums you use, wood being one. Can you talk about how some of the materials like wood and metal react to certain outside forces? You sort of touched on that a bit more, and what the applications could be, maybe in a smart city or in the sort of smart building environment.
Yeah, and it's funny because a lot of people think of our lab as a material science lab, but realistically, as you said, we don't invent any new materials. I mean, we're working with sand and wood and metal, and foam and rubber. We're working with everyday materials that are abundantly available, that we've, as humans used for decades, if not centuries or longer. And we're just trying to tap into their innate ability to respond and transform. We're trying to augment them or fabricate them in new ways. And we look at smarter materials and environments from that lens, that there's lots of things we can do with our everyday materials just by activating them or fabricating them in new ways. And so wood, for example, swells based on moisture. And we all know that. And in the furniture space, that's like the bane of their existence, is to stop wood from morphing. Or look at 2x4s. We've taken this anisotropic, like complex, beautifully organic material of wood, and we've tried to standardize it down into 2x4 lumber and say it's a standard material when it's not. So we could activate these materials to take advantage of their unique ability to swell with moisture and create smarter products. metals respond to temperature, for example. Lots of plastics respond to temperature or moisture. So every material is going to respond to some activation energy, and it's just trying to find that and tap into that to do something useful.
I mean, it's fascinating. I mean, we've only got a very short amount of time for this conversation initially, and there's such a body of work that you have. And I understand that you have a book coming out, and it's called Things Fall Together, A Guide to the New Materials Revolution. That's coming out next year, and some would call it a manifesto. Could you outline your manifesto just in our sort of final few moments?
Yeah, the book is really about the principles that we work with in order to activate these materials and these environments. And, as you were talking about before, it's just about a change in perspective on how we create and adapt in our environment. That typically we think of smart machines and smart computers, maybe smart humans, but if you think about smart humans, we're just made out of materials. We don't have chips and batteries and motors in us. And so we've sort of lost that ability, and just by collaborating with materials, we can create smarter products, we can create in a smarter way, and we can create much more sustainable environments by being able to adapt and shift on demand with these fluctuations. And so the book is really about the principles that we go through in order to design and create and collaborate with these material environments.
I love it. And, you talk about us being like made up of like DNA and cells and all those other like bio things. I'm augmented by my mobile phone. Like it's become a device that I depend on for a memory storage, actually. I can remember what meeting I had and I can use a prompt in my calendar. But equally, I'm depending on like my wearable technology to tell me how much I've moved. There's so much we could dive into and carry on talking about. Your book is out next year in June, and I'm sure the team will place some information about that. Skylar, it's been an absolute pleasure. Like, I cannot tell you how exciting it is to see how collaboration is really at the core of what you're doing. And if there's anyone that you want to reach out to, or someone who should reach out to you and your team about collaborating on other ideas, how can they get in touch with you, and what are you looking for?
Yeah, I mean, collaboration is exactly, and all the times that I present to any group, it's always about let's do something together. We want to learn about different industries and different problems around the world. And, that's where the Maldives project came from, was just a pure collaboration, someone reaching out with a problem that they were facing in the Maldives, and that project emerged. So we're looking for different teams and projects that we can apply these principles to come up with solutions together and learn about different problems in the world. But they can look at our work and follow what we're doing at the Self-Assembly Lab's website, selfassembly.mit.edu. That's probably the easiest way.
Fantastic. I'm particularly interested in how we can take your learnings, and as we go back to the moon and onto Mars, how we can build creatively and in line with the environment there, but also, as you're doing, using that technology to make our planet a better place. Skylar Tibbits from the Self-Assembly Lab at MIT, thank you for joining us at CogX Spotlight today. I've been Nish, and thank you all for joining us for this session. Stick around for the next one.